One last thing I want to talk to you about in these videos, and this is something that I disagree with most textbooks about because, I don't know, I think it's just wrong. The point here is that where there is a factor we leave out in molecular forces, and this is the idea of molecular weight. Now, if you were to look at something like alcohols, and with the alcohols, if you start adding more CH3 groups, they get more and more nonpolar, which means their boiling point should go down. They should boil much better because they're less polar. We see the opposite trend actually. As they get heavier, it takes more and more energy to boil them. So books will lump this in with dispersion forces, saying, well, it's more polarizable. Not what's really going on. What's going on is at the end of the day, at a given temperature, all gas molecules have the same kinetic energy. So we have this relationship Ke equals 1/2 mv squared. As molecular weight goes up, that m goes up, the velocity goes down. To escape the liquid phase, you have to have a high enough velocity that you're not going to be recaptured by the liquid. I mean, it's kind of like saying you're going to leave a group, but you're going to do it really slowly so you don't ever do it. Kind of the same thing with these big bulky molecules. They're too fat and lazy to actually get out of liquid phase into the gas phase. So while you do need to understand molecular forces, they do play a huge role, it's not the only thing that's going on there. If you take a really, really heavy compound like a tar or naphthalene or something like that, it's not sticking to itself because of strong intermolecular forces. It's sticking to itself because it's just so bloody heavy it can't get into the gas phase. So just keep in mind, we're not going to really talk about that much in the course, but do understand that IMFs, while they are a huge part of understanding physical properties, they are not the only thing that dictates the liquid and gas phase behaviors.